Eh. Now, we can actually apply conservation of momentum if the collision is in two dimensions lah. So what does it mean by two dimensions? So one dimension means it's along a same straight line which is what we used to do earlier on. Right? For example, the one ball comes here, hits another ball, so both either move forward or one move backward, one move forward. That's one dimension because we're talking about only this length. But two dimension means it will move here and also here. That means there's a x and a y axis. So when you move in x and y axis, all you have to do is you will just have to break down the momentum. That means you will still use conservation of momentum, but you will now say the total initial horizontal momentum equals to total final horizontal momentum. And then total initial vertical momentum is equals to total final vertical momentum. You just have to resolve all your momentums to two dimension. Example, if let's say this white ball here hits a stationary red ball, when the white ball comes in straight, the initial momentum is only a vertical momentum, right? Because it's moving upwards, right? So the total initial vertical momentum, let's say is P, but the total horizontal initial horizontal momentum is 0 because it's moving vertically. Then after hitting the red ball, let's say the red ball moves here and the white ball moves here, then we can find the total vertical momentum after collision. So total vertical momentum after collision, that means if I know this is my momentum, if I have an angle, I can resolve my momentum into horizontal and vertical, right? So I will take the vertical momentum of this white ball. I will also resolve this momentum to horizontal and vertical, and I will take the vertical momentum of the red ball. So if I sum the momentum, if I sum the vertical momentum of the red ball, which is here, and also sum the vertical momentum of the white ball, which is here, total together, I will get my total initial vertical momentum. But remember my total initial horizontal momentum is 0 because the ball was only moving upwards. So after collision, if I take the horizontal component for the white ball, horizontal momentum of the white ball, and the horizontal momentum of the red ball, can you see the opposite directions? So if I sum them up together, they must give me 0 because the initial was 0. So if you look at the diagram here, you can see this is the momentum. This is just the arrow represent the momentum. So if let's say this is my momentum initially, okay. So if I were to break it down after the collision, so I will have two momentum. So if I resolve this to two components and resolve this to two components, the vertical plus vertical will be equals to this. But the horizontal and the horizontal will cancel out each other. That's what you're trying to say. So now this is a vector diagram. So that means if this is my initial, my initial is here. So it will become this plus this. Because my total initial momentum must be equals to my total final. That means this final plus this final must be equals to this. But this one we rarely use this. What's important is what I told you. Just use the horizontal and horizontal equals, add together equals to total initial, vertical and vertical, add up equals to total initial, that's all. Okay?